Alright, so this is the vocabulary for wave behavior. Remember, every packet, just about every unit has a vocabulary. For the vocabulary, you'll need to write the word, write the definition, and then use it in a sentence. If you want to, you can do a Freyer model for each of these, and if you do a Freyer model, let me know and I'll give you a few extra points on your test. So, let's go over the vocabulary. Alright, so the first word is resonance. Excuse me, I was going to say resonance. Ugh, it's a weird word, right? So resonance. Resonance is, let's do the definition first and then we'll sort of do the normal person definition. So if you clicked on your physics classroom deal from Canvas, they give you the definition right here. When one object vibrating at the same natural frequency of a second object forces that second object into a vibrational motion. So what that means is when one object is vibrating, if it's at the same frequency as another object, that second object will start vibrating as well. So have you ever seen a video, and I think I have one on Canvas, where somebody like sings at a glass, and if they sing at just the right vibrational pitch, the glass will start vibrating too and eventually shatter. And I think that's a part of your lab where you is it this one? I want to say it's with this one, where you rub the top of a wine glass, and if you wet your finger a little bit, it'll cause that wine glass. It'll put a vibration in the glass at the same frequency that the glass is vibrating, and pretty much it amplifies it and shatters it, right? So, to summarize the first definition, when one object vibrates at the same frequency as the second object, and the second object will start vibrating as well. So, that's the first definition, and let's move on to the second one. Okay, so we just did resonance. Why do I keep saying renaissance? I don't know. Alright, constructive interference. So let's cover interference. Remember, you can use Physics Classroom to find the definitions of most of these. So interference is when essentially it's when two waves meet and what happens as a result of that. Okay? So if you can't find a word on Physics Classroom, by the way, just Google, like, for instance, for this one, constructive interference. Google Physics Classroom constructive interference and it'll take you right to the page. You know, because some of these I give you guys links, but it like takes you to like a million things and it's kind of hard to navigate. So remember, just Google like Physics Classroom and then the word, and it should take you like right there. So constructive interference. So that is when two waves meet, two of the same waves meet, and the aftermath of those is a bigger wave than the two individual waves. So they gave you a picture, and I'll kind of sort of draw one. You have wave, let's say it's, what is that, 3 millimeters high wave, right? And it's going to the right. And then you have another wave, 3 millimeters high, and it's going towards it, right? The combined wave, construction means to build something up, right? So the aftermath of that wave is going to be a higher wave. It's sort of like just combining your powers, right? You have somebody lifting something, they can lift 10 pounds, another person lifting 10 pounds. They both combine and then they lift 20 pounds altogether. So this is supposed to be double these two. Constructive interference. Oh, actually right here, if we scroll down a little bit. Type of interference that occurs in a location, blah, 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 blah. When two waves having a displacement in the same direction, in this case both waves have an upward displacement greater than the displacement of the two waves. In other words, it just added together, right? So you have these waves here. They hit each other. It adds together. The green is the new wave, right? So I know you're going to have this either in your unit or on your test where you got to draw constructive interference. You'll draw two waves coming at each other, and then the new wave is going to be pretty much double the two waves, right? Pretty easy. So let's talk about deconstructive interference. It's the opposite. You have two opposite waves. Notice the red and the blue on the Physics Classroom. When they hit each other, so let's bring this over here. You have a wave like this, and then you pretty much have the exact opposite wave. Let's assume these are the same wave, and they're going towards each other. The resulting wave, if it's the exact same wave, should just cancel each other out, right? So if you're ever in a swimming pool, right, and you push a wave at somebody, you're facing them, right, and they push the exact same force and amplitude of wave at you, when those waves hit, they sort of just neutral out, Okay, so the new wave is like a flatline wave. So that's deconstructive, right? Deconstructive does not always flatten out, as you see in this example. You know, if they're different lengths of waves, the new wave, it's almost just like you subtract. So like you can see this blue wave here, it's a little bit higher than the red wave. This is deconstructive. When they hit each other, the new wave is a weaker wave, right? So that's it. It's pretty simple stuff. Before interference, after interference, it's pretty straightforward. So constructive, 1 plus 1 is 2. In the same way the other way. This would be if the wave was like a bottom wave. Call that negative, right? When they're coming at each other. -1 plus -1 is -2. Deconstructive, +1 plus a -1 is 0. It's deconstructive, right? And another deconstructive is when they're not equal, like +1 plus a -2 brings that down to a -1, right? So that's just a deconstructive interference. So one adds together, one subtracts. So that's the next one. Okay, last word is diffraction. So it's not refraction, by the way, it's diffraction. Process by which light or beam, a beam of light or other system of waves spread out as a result of passing through a narrow aperture or across an edge. So that's just light tends to spread out when it passes over or through something. So it starts off as a beam. When it passes over, it tends to spread. So let's look at some examples because it's kind of hard to visualize without them. So let's say you open a door into a dark room, and so you open a door into a light room, and you know there's light on the other side. That light, notice it sort of spreads out, right? Sun rays, so that would be light coming around corners. If you shine a flashlight sort of like along a wall, as it hits that edge, it'll spread out. Light diffracting through clouds, notice how it sort of spreads out. Most everybody has seen this. Light peeping out through two blades when they are placed in a manner. Well, that one's a little bit, yeah, so light sort of like comes out. So, diffraction. Again, it is the process by which a beam of light or other system of waves is spread out as a result of passing through a narrow aperture or across an edge. So there you go. That's diffraction. That's all your vocabulary words. Make sure you guys follow the deal where you give a definition, name definition, and use it in a sentence, or you can do a Freire model for a little bit extra points. You just got to let me know. Let me know if you guys got any questions.